So case studies, PDC did a lot of work in the early days as they were preparing this system with customers out there, and then have done other work since. One that you'll see there's examples of this, more detailed stories about this on PDC's YouTube channel and the like. But Jacobs Engineering, so this is the one I showed in the early slide. So Jacobs Engineering make basically stuff for space. Okay, so they are making the portable life support system, the PLSS, that they're developing for NASA, which is see there on the back of an astronaut. So obviously weight is critical for this because you're going to send that up on a rocket. So absolutely you want to minimize the mass of that. So they used generative design to look at three components. We're going to look at one of those, which is the CO2 sensor bracket. Okay, so essentially they have the original design shown here, which is to basically position and mount some CO2 sensors to obviously monitor the amount of carbon dioxide in the air that is being sent to the astronaut. Okay, very critical. So they took that original design that they had, they defined a design space, they defined some interfaces into that, what was critical, and then fed that into generative topology optimization. So there was some rules around, obviously stresses that it had to be able to handle. I think it was 18.5 Gs in any direction. Okay, so basically this is what they came back with. Okay, so the original weight versus the generative weight. So they reduced the weight by 20%. Okay, and reduced the peak stress by 73% using generative design. Okay, so that's a fantastic result. Obviously, with every single little gram being very important when you're setting it up into space, we'll still be able to maintain the structural requirements of that design. Okay, they did look at other options. You can see this one here is very, I think that one's completely additive, printed, but they did also look at other options around, being able to machine them. So again, that's the beauty of generative. You are not limited to just additive manufacturing, right? You can define constraints that mean I want to machine or cast or mold this particular item. All right. So that's a bit of a look there at some of the generative tools. Okay. So just to I guess just to summarize, generative design inside Creo. Okay, so uh, it's a native solution that is completely embedded inside Creo. So it's not like you're having to learn another package, learn another UI. It runs native there in Creo. Uh, it can automatically generate solid geometry for you from that result. So again, there are other solutions out there, third-party solutions that will take geometry from, CAD tools and build that, do that optimization. But the general problem is that you end up with a faceted model. So how do you then take that faceted model and actually do something with it back in CAD? You've got to go and reconstruct that yourself, which can often be a very time-consuming and painful process. Okay, so with Creo, it's literally say build me a part, and you end up with a finished part. Okay. And if it doesn't get 100% of the way there, it'll generate the majority of that surface for you automatically. And then maybe you can use the surfacing techniques to patch that up and finish it off for the complex bits of geometry. Okay. And the other thing is it's scalable. Okay. So if you've only got a few things that you're looking at, that's great. You can choose to run them on your desktop one at a time, and that's fine. But if you're looking at, really massively optimizing this design with potentially, hundreds of different options, maybe thousands of different options that you're trying to evaluate, because weight, cost, whatever it is critical, then we can also add on the ability to scale that up and use all of that cloud compute power to come up with a more optimal solution based on more results and more runs. Okay. So, the main thing is, why are we doing generative? It's really to, give us better business value. Okay, so it's to lower the life cycle cost, get better products to market, maybe design something that's more innovative, and differentiated from our customers because it's lighter weight, performing better, whatever it might be. We want to look at, improving the product quality and performance, and really also to reduce that product development cost. All right, why have engineers spend hundreds of hours trying to come up with an optimal design when the computer can go off and calculate that itself? Okay. So that's what we want to talk about in terms of generative design solutions from Creo.